after World War II, this guy reached out to MIT and he was building basically helicopter rotor blades.
The only way they could do it was to buy Fanuc CNC machines, which would hand carve each of the exterior shells of an iPod, an iPhone, and things like MacBooks.
That's the wrong question to ask. Welcome to Supply Chain. I'm John from Asianometry.
I'm Tim Culpan from Culpium. John, today I want to talk about Fanuc, the Japanese company, Fanuc. Fascinating company. Tell me about them. I mean, they're a machining tool company, CNCs, all that kind of stuff. What's the basic history of them?
You know, I think in order to know Fanuc, right, you need to know what machining is, right? And machining is they call it like the fundamental, it's the foundational part of all technology. Any piece of metal that you see today has to be machined by a machine tool or machined by something that machined a machine tool. So it's kind of like, it's not a very big part of the industry, or of the economy. It's like a very small percentage. Like the whole industry is maybe like less than $20 billion or something like that. But it's immensely important for sophistication of technology. So like, in Fanuc came in the 50s, but before that, it did something that was done by human machinists. And this is kind of like a fascinating thing where it used to be that machinists would be a person that was trained in math and engineering because they have to machine these very complicated like steel or metal items. And which meant that you had to learn all these mathematics. They had these tables. I'm reading these machine tool handbooks, and you had all these really fascinating things. But then you needed not just like a mathematical mind, but also a kind of a feel. You had to really do
art and science.
Yeah, it was art and science. And like I really enjoyed learning about that. And I think but one of the, there's a social aspect to it too, because it means that the machinist will always be a participant in the product.
So they're the artist behind the end product, really.
Right. But if like anyone wanted to make and mass produce a machine item, like a metal item, the machinist always has a participation in it. Because they're the one always they're feeling it out, they're cutting it up. But that wasn't good for industrial production, right? Because every machinist is different. And like that led to problems.
So consistency was part of the challenge.
Yeah. And after, I would say, World War II, they were this guy reached out to MIT, the university. And he was building basically helicopter rotor blades. And so he had an idea to make these rotor blades, or he was making rotor blades, and he used this machine to kind of, that almost like those player pianos? Like you draw out kind of like a design or something, it would just automatically play the song. It kind of was like that, but for machining. It would kind of it would follow a number, follow a line, which is why they came up with the name numerical control.
Right.
So like he got a contract for the Air Force. And so he worked with MIT to say, we have this milling machine. It's going to be controlled by this group of numbers, this sequence of numbers. And so they worked on this, and it was a total mess. Went hugely over budget. Guy dropped out, all that. But they finished it, MIT, in 1951, and they kind of 52, and they presented it, and they were like, look, this is a mechanical brain.
It's the future.
It's the future. It really is the future. The two scientists were talking about, like, this is an amazing thing and all that. Everyone looked at this as, like, totally impractical and all that. But the work that was done at MIT comes to Japan. The people in Japan hear about it, and they're like, this is kind of interesting. One of the companies that looked at it was Fujitsu.
Oh.
Fujitsu, the computer company.
Yeah.
They were Japan's leading computer company at the time, competing with IBM and all that, mainframes. And so they get a bunch of guys led by this guy called Suemon Inaba. Basically, it was like a little dictator. They called him Compact. And he was at Fujitsu as a mechanical engineer. And he was basically like, we will start from scratch. and we will build this machine. They took the MIT papers, they learned it all, and then they started building what are called numerical control systems for machine tools.
Huh.
They made little progress, and then they made a critical decision to say, we will only work. We're not going to make the machine tool. So this is the important distinction. They don't make the machine tool. The machine tool, you can imagine as like the muscle and the skeleton. They wanted to make the brain and the nervous system.
But not the tool itself.
But not the tool itself. It attaches to the tool and controls the tool.
So we will make the control system for the tool, but someone else can deal with the tool thing. That's not what we want to do.
Yeah, like Makino or something like that. They will make the machine tool. The Makino will sell the machine tool as a combined system, but the controller is made by Fanuc. Or Fujitsu at that time. Fujitsu numerical control at that time. They started building this machine. They had the advantage of working with Fujitsu and all that, and they built that and turned it into a significant business, actually a very profitable one, unusually for Japan at that time, because they really nailed the part in the integration supply and all that. And they would talk about the controller module at that time, the numerical control module was really important at that point, high margins and all that. They spun off by Fujitsu as Fanuc. Fujitsu Automatic Numerical Control.
So that's where the name comes from. Fujitsu Automatic Numerical Control.
Yep.
FANUC. There you go. Fascinating.
Yeah. I never knew that. I always thought it was some sort of funny sound.
Yeah.
No.
It's just an abbreviation.
And Dr. Inaba basically led this company for like forever, basically. He was a very quirky guy. He was really into robots. He was really into the color yellow. He was really into, he moved the whole company out to the middle of nowhere, Fanuc Forest, at the foot of Mount Fuji, for some reason. He was a very interesting guy, kind of like those really visionary types. He actually was, I would say. One thing I was really admire about Fanuc is that throughout the 50s and 70s, they really jumped onto every technological trend, right? Like they jumped onto transistorization.
Wow.
They jumped onto the integrated control, the microprocessor. They used one of the first Intel chips.
Wow.
And I think one of the critical things is that they took on the electric motors.
So they really were quick to adapt to new technologies.
They were. And so they built up this huge ecosystem. They and the number two, I think, company is Siemens. In after numerical control was really adopted, they added the computer to it in the 1970s. Ergo, CNC, computer numerical control.
Okay. So numerical control was really the foundational idea, very mechanical, very analog.
Yep.
And then with computers, transistors coming along later, they could just basically have the computer do the numerical.
You can actually do the design in the computer.
Right. Yeah.
But prior to that, you actually had to an engineer had to convert the design or where the cut is for the metal. That had to be done by an engineer to convert it into the player piano script.
Interesting.
It was weird. And then CNC came along and kind of changed a lot of that. But I would feel that the real game changer was the introduction of the microprocessor, the Intel microprocessor, and the switch over from hydraulics to electric drive, which really kind of helped them get more precision.
Yeah.
And Fanuc really navigated those transitions really, really well.
Seamlessly, because it seems, looking back, obvious the path they would take, but actually historically, not necessarily, because each one of these new developments had to come along for them to move into it.
And I think they really did better. There were other companies at that time or earlier making controller modules as well. But I think Fanuc really made the right call when they were working with all these different machine tools, because then they got to see all the problems that their machinists were trying to solve. And so it required a lot more specialty that these machine tool companies in America could not do. The American tool companies were machine tool companies. They're machinists. They were making milling tools and stuff like that, lathes and all, cutters. And they didn't know computers. They didn't know how to make all this numerical control stuff. A lot of them failed.
Yeah.
And there are other structural issues, but yeah, a lot of them failed.
Fanuc, I know, getting into the 1990s into the 2000s, because of CNC and what they could do, really set the path for mass manufacturing of electronics. And a good example, I think, is Foxconn, who were doing electronics in the late 90s, not really before the late 90s. Before the mid-90s, there was just basic computer parts, but it was into the iPod era and early PlayStations and stuff that they got into end-to-end vertical integration. But then it was the iPhone era, the iPod and then iPhone era, and they needed to scale quickly. And Apple, amongst other clients, had very specific mechanical needs of the specific design of the chassis of their products, the exterior of their products. And the only way they could do it was to buy Fanuc CNC machines, which would hand carve each of the exterior shells of an iPod, an iPhone, later things like MacBooks, by hand. And so Foxconn would go out and just buy out everything off the shelf, so to speak. They would go to Japan and we want 1,000 of these at a very high price. But they would go out and buy thousands of them in a go. Or Apple would buy it and they would just corner the market on it. Because Terry Guo and Foxconn, as well as Tim Cook, understood that this is the only way we can do it is with these CNC machines that are kind of handcuffed, yes, by a machine, but it's not mass stamped like injection molding or various other types of molding to get a mechanical product. They were basically, each one was carved individually. And the only way you could do it was with a CNC system that Fanuc had cornered the market on. And only through that could Apple have ever mass-produced all of the iPhones, the iPods, the iPads, the MacBooks, all these things that they do that require CNC machining to create the product the way they do.
Yeah. I mean, it's an incredible achievement that Fanuc managed to build, along with Siemens. Let's not
Siemens,
give
important
them
part of it.
Give them credit too. I think, but yeah, Fanuc really hit a home run with
Now, this seems like the obvious area where the Chinese would want to get into. It seems like, okay, the Japanese did really well. They nailed CNC. Fanuc, along with Siemens, which is German, had this market cornered and mastered it. But you can imagine the Chinese going, this should be something we get into.
You would think so. And actually, they've been targeting it in their policies for decades. And I would say that, but so far, as far as we can tell, Fanuc and Siemens still control, I would say, 70-80% of the market on CNC controller modules. And it's kind of really interesting because Chinese companies have tried to actually defeat the Fanuc ecosystem or the replace Fanuc as a controller module. It's not as easy as one might think. And you have to, it is clear you need to differentiate machine tool from controller module, because a lot of Chinese tools will be shipped it will be a Chinese tool, but the
control system
is the control system Japanese, or is it a Chinese machine or controller module?
So which Chinese names are or have been trying to get into that game?
The biggest one, and the one I've done a video about, is Shenyang Machine Tool. They are one of China's oldest machine tool companies. They've been around since they were a Mitsubishi machine workshop that got nationalized after the war, and they basically became one of China's top machine tool companies, and they were making these really old machine tools that for decades. And in the after the economic opening up, they really fell into huge trouble, lots of debt. They really fell behind in the 70s, not just Cultural Revolution. They missed the CNC revolution entirely. They didn't have access to Intel processors. They didn't really have the expertise.
So they were holding on to the old school machine tooling processes when NC and then CNC came in.
Yeah. They were selling a machine tool that was 70 years old. Design was 70 years old. And so in 2000s, they tried to move on fast. The interesting thing, right, is that the Fanuc entered the Chinese market very early, 1980 or something. And they quickly dominated that market. And I think one of the things about that is that for Chinese manufacturers, they needed the absolute best performance. That had to be Fanuc. So that actually turned out to be one of the reasons why Shenyang struggled to achieve and keep up, because their customers couldn't tolerate worse performance. I would say in the 2000s, at around 2007, 2008, they said, the party came to them. One of the party members came to them and said, you can't be making this old stuff. You need to go to the future.
You got to modernize.
You have CNC. You got to make a Chinese CNC. You need to replace Fanuc. So they spent about $1 billion developing a domestic product called i5. i5 is their platform for CNC control. They had this really flashy debut in 2000, I would say 14, when they're saying, "Oh, we're gonna i5. It can do all these different things and all that."
The future, Chinese enterprise.
Chinese enterprise. The government really local governments work with them and put a lot of subsidies and all that. I think the problem, ended up that the company fell into bankruptcy. It almost, by 2018, they were basically collapsing.
Were they any good compared to Fanuc? Close?
I think that's the wrong question to ask. There were things about them that worked really well. It was on the cloud. It was connected to the internet. It had certain applications that were pretty good. I think the hard part for me when making this video, for understanding how powerful Fanuc was, the ecosystem of Fanuc and Siemens together, was that you have to understand the kind of the ecosystem that's around it is more than just the software. It's all about the stuff that integrates with it. It's all about
works with everything.
Works with everything. Who uses it? Who's been trained in it? You have people who've been working with it Chinese people who've been working on it for 30 years who know it really well, right? They've contributed software to it. All that. It's kind of like, I think someone,
like Windows or something.
It's Windows. It's operating system. It's like as if one of the Chinese companies shipped an OS that's like they vibe coded their OS. I mean, it works. It'll open, you'll get start, but where are the applications? Where's the browsers? Where's all of this?
Everyone's already built around Fanuc. Why would they swap it to something that's only just as good?
Yeah, or slightly less. And then Shenyang, they of course they knew this, but the business model that they took was that we're gonna make this rental. We're gonna pay by hour. You don't have to buy the tool anymore. You have to rent it. You can rent it. They really want to make the bar of entry really low. That's kind of like the Chinese way. Make it cheaper. Make it cheaper. Make it cheaper. And I would say that maybe could have worked, except for the fact that they were like a horrendously debt-laden company.
And so they couldn't really survive long enough to build an ecosystem.
They couldn't survive the 20, yeah. It would have taken 10 years, 10 plus years. But they got some success in 2 and 3 axis tools, which is like
the simple stuff.
The simpler stuff. But 5 axis, they only shipped that, and then only 200 companies were using it, or 200 units were actually in use. They did a survey, I think, in 2021. They found that only 200 of them were actually being used, and all by military companies. So it was at that time, the industry was already very much in withdrawal, like they were shrinking, and the company was suffering really bad. And they ended up filing for, they didn't file for, but they got taken over by the state. And they remain being under reform.
I do see the parallels between their attempt, Shenyang's attempt at being the next Fanuc, the Chinese Fanuc, and Chinese attempts to doing a Red OS to replace Windows. When you're trying to do that, yeah, it's okay to be as good as, but you've got to have also the whole ecosystem that everyone's built around, and you've got to find a way to get all those people onto your platform, which is usually through money or incentives, or the government decrees it, which you can do in China. So you need to have follow through. You need to have another 20-year plan after you've got to that point of actually releasing a product. You need to have the next 20-year plan of forcing everyone onto it.
Yeah.
And then having the industry accept that they may not get the performance or the output or the throughput or the efficiencies from the locally grown version, but that's okay because in the long term it's better for us.
Right.
And then the government's got to decide if they're going to subsidize industries who are going to lose by being forced to take a lesser local product while they build it out. And so there's many, many parts of that policy puzzle that Beijing would need to deal with to try and make Shenyang a real winner. Yeah.
Can you imagine if Foxconn, if China, or all the Luxshare or something was sold, you can only use Shenyang. You can't use Fanuc, right? It'd be do you think they could churn out iPhones? Probably not.
Right. Well, I guess the similarity is now the Chinese and AI chips when, first of all, the Americans, but then the Chinese have said you cannot use foreign AI chips, you must use local. Well, we see DeepSeek and so forth who are distilling, but they really are a GPU poor, as Dylan Patel would put it. They are struggling. They are behind. They could do a lot better if they had the best chips in the world, but they don't. So they have to do with what they can, and they fall behind. And the only way to get around it is through a different approach. Distilling, which is not the same as building the models from scratch. So that's kind of the modern example. And I can see why Shenyang had a valiant attempt at doing it, but making the product is only the first step in kind of winning.
I really admire that they tried. I mean, there's other companies in that industry because it's really important, I think, to differentiate because these are northeast, the Liaoning areas. Like this is northeast China. This is like Mongolia area, and this area is not doing well economically. Like we're not talking about like Shenzhen, the really rich Guangdong, the small like Hangzhou and all that. This is a very struggling area. And I think this area they needed Shenyang to come through, and unfortunately, that company has had a lot of baggage. In some ways, that baggage that means they're the only ones who could have done it, but also means it also kind of ended up killing them in the end.
Valiant attempt by Shenyang to step up and beat Fanuc at its own game. Almost made it, but not quite. This has been another episode of Supply Chain. I'm Tim Culpan from Culpium.
And I'm John from Asianometry.
Thanks for listening.